Good afternoon, Doctor. I'm Ng Keng Yen, metric number U2104524. We are from Group 6 and our group will be presenting our assignment, which the topic is hand truck.
Greetings, Dr. Chan. My name is Ryan Chan Kai-boon, matrix number U2103533/2.
Hi everyone and Dr. Chan. My name is Ng Wilson and my matrix number is 22004691.
Hi everyone and Dr. Chan. My name is Ng Hui Ping and my matrix number is 2204631.
Everyone and Dr. Chan. My name is Chong Ziyang and my matrix number is 22004664.
Now, I would like to talk about the objective of our assignment. So for our assignment, we have allocated 2 objectives. Now, the first objective would be to illustrate static learning outcomes using everyday applications. There are 6 learning outcomes which was required for us to achieve for this assignment. The first would be to use free body diagrams to perform equilibrium-based analysis for various structures. The second would be to solve problems involving a body under the action of axial, bending, and torsional load. Third would be to employ moment and inertia-based analysis for problem solving due to compound load. Fourth would be to evaluate stress and deformation of biomedical devices. And last but not least, to perform effectively as a team in analyzing real-life cases of static objects under loading. And our second objective would be to find real-life examples of any static and mechanics of material structure or movement from around us.
Thank you Ryan Chan Kai-boon for explaining about the objective of this assignment. Now I'm going to make an introduction for this assignment. Here is the 3 main ideas we are going to talk about for this introduction. The first one is the static and mechanics of material, and the second one is the moment of inertia, and the last one is the action of axial, bending, and torsional loads. Static and mechanics of materials are 2 branches of engineering that deal with the behavior of objects under different loads and stresses. Static analysis involves understanding of the stability, equilibrium of the objects when subjected to external forces. This can be done through the use of a free body diagram which represent an object and the forces acting on it. The free body diagrams helps to determine the force acting on the end object and the resulting equilibrium. In mechanics of materials, the study of how objects respond to the external forces and stresses is performed, including the understanding how they deform and fracture under different loads. So the objects can be subjected to various types of loads, including axial, bending, and torsional loads. In physics, the moment of inertia is a quantitative measure of a body's rotational inertia. That is, the resistance that the body exhibits to have its speed of rotations along an axis altered by the application of the torque. The axis might be internal or external, and it can be fixed or not. The moment of inertia, on the other hand, is always expressed in terms of the axis and is defined as the sum of the product produced by the multiplying the mass of each particles of matter in a given body by the square of its distance from the axis. Now we are going to talk about the action of axial, bending, and torsional load. Axial loads refer to the forces acting along the axis of an object, such as tension or compression. For the bending loads occur when an object is subjected to forces that cause it to bend or deform, such as bending moments. And lastly, for the torsional loads refer to the twisting forces that cause an object to rotate around its axis, such as torque. The study of these loads and how they affect an object helps to determine its strength and durability, as well as any potential design weaknesses or areas that may need improvement. Therefore, an experiment is conducted to find a real-life example that can be used to show and describe one of the learning outcomes in KIB1011, Statics and Mechanics of Material. In this experiment, hand truck is chosen as the real-life example to explain about its action of axial, bending, and torsional load. A hand truck is an example of a manual materials handling equipment that is intended to reduce the physical effort required to do the manual material handling tasks. For example, rather than lifting and carrying 10 individual boxes from one area to another, a worker can support the weight of the boxes with a wheeled cart. Hand trucks encourage employers to transfer big goods efficiently and safely. And as a biomedical device, hand trucks are commonly used to transport a manual biomedical device in a healthcare setting. Biomedical devices such as medical equipment, imaging machines, and supplies can be heavy and difficult to move. Therefore, hand trucks provide a convenient and efficient solution to this problem, allowing healthcare professionals to easily transport these devices from one location to another. The compact design and the maneuverability of hand trucks make them ideal for use in tight spaces such as hospital rooms and laboratory settings, where larger equipment and vehicles may not be able to fit. Additionally, hand trucks are often equipped with straps or other securing mechanisms to ensure that biomedical devices are securely transported and protected during transit. Now, we are going to proceed to the methodology. In this experiment, the hand truck was chosen to be the structure that we are going to be analyzed, and the dimension of the hand truck was measured and recorded. In order to investigate the relationship of the structure of a hand truck with statics, some procedures are required to be carried out. First, free body diagram is constructed. Second, SL load testing is done. And the third, bending load testing is done. And fourth, torsional load testing has been done. And lastly, moment of inertia experienced by the hand truck and the radius of gyration are calculated.
Let's enter the results section. The objective of this assignment is to identify a biomedical device that includes learning outcome 1 until learning outcome 3. The results section includes forces of equilibrium, action of axial, bending, torsion, and moment of inertia. The first part is the force of equilibrium. We assume that the load is a box of 24 500 ml mineral water and the dimension of box is 39 × 26 × 22.5 cm. This diagram shows the component of forces on hand truck. The diagram on right hand corner is the free body diagram. We let the reaction at back wheel in y direction as RA. Since there are two back wheels, so it will be 2RA. Then we let the reaction at front wheel in y direction as RB. Since there are two front wheels, so it will be 2RB. For external forces, the mass of the handle is assumed to be negligible. All forces are calculated in such a way that the truck is assumed to be stationary. Firstly, we calculated to obtain value for total weight, W. Then, we assume moment at A is equilibrium, which means equal to 0. And we will get the value of RB, which is 66.2175 Newton. Next, we assume all external forces are in equilibrium, and summation of F in y direction is 0. And we will get the value of RA, which is also 66.2175 Newton.
Now, I will be presenting the actions of axial problem. From the diagram of the hand truck, we can see a force of 60 kN is applied. The assumptions that we made are the wheels are assumed to be fixed on the ground and the member QR and PQ are made of standard steel. We can determine the force experienced by the member QR and PQ by applying the summations of Fx and Fy is equal to 0. We will get FQR is equal to 17.32 kN and FPQ is equal to 10 kN. Then, with the force we obtain, we can now determine the deformations of the members by using the formula of PL per AE, which the answers are 3.513 times 10 to the power of negative 6 meter for QR and 2.504 times 10 to the power of negative 6 meter for PQ. Then, by using the formula stress is equal to P per A and strain is equal to delta per L, we can get the value of stress and strain for members QR and PQ. Now, we can see the stress strain diagram of the standard steel on the right side. As you know, standard steel is a ductile material. Remember, QR and PQ behave elastically if the strain disappears when the stress is removed, while they behave plastically if the strain does not return to zero after the stress is removed. Proceeding to bending problem, by using the information from force of equilibrium, the load is applied at the center length of the horizontal member and the reactions at B and D is determined. Then we can produce shear and bending moment diagrams. From A to B, the V and M are equal to 0. From B to C, by using equilibrium equation, we can get V is equal to 132.435 Newton and M is equal to 132.435 x, which the line will increase linearly. Now we can draw the shear and bending moment diagram from A to C. Then we repeat the same method to obtain the shear and bending moment equation from C to E. From C to D, the shear is equal to negative 132.435 Newton and the bending moment is equal to negative 132.435 x plus 43.704, and we get 0 for both shear and bending moment from D to E.
From bending moment diagram, we get the maximum moment is 43.704 Newton meter. Then, we apply formula I equals to 1 over 12 BH cubed to find the area moment of inertia, which is equal to 2.56 times 10 to the power of negative 6 meter 4. Then we calculate for maximum normal stress by using formula sigma maximum equals to mc over I, which is equal to 341.4375 kilopascal. The next part is torsion. We assume that the shaft of both front and back wheels are solid circular shaft and diameter of 2 cm. The diagram shows the component of forces on hand truck from front perspective. For torsion of back wheels, the diagram below is the free body diagram of back wheel shaft. From force of equilibrium, the RA obtained is 66.2175 Newton, and Tn is 52.974 Newton meter. We apply summation of torque is 0, and we will obtain value of both T1 and T2 is 26.487 Newton meter. Then we apply formula J equals to 1 over 2 pi C power of 4, and we will get 1.5708 times 10 to the power of negative 8 meter 4. Then we find the value of maximum shearing stress by applying formula sigma maximum equals to Tc over J. The final value that we obtain is 33.724 megapascal. For torsion of front wheels, the magnitude of torque is the same as back wheels, except for the direction of rotation is inverted.
Lastly, for the moment of inertia problem, we determine the moment of inertia and the radius of gyration with respect to x and y axis by using the side perspective of the hand truck. First, to determine the moment of inertia for x axis, we need to divide the hand truck into 4 parts and find the moment of inertia for every part by using the formula central inertia plus the area of the parts times with the square of distance from the axis to the centroid point. After obtaining the moment of inertia for every part, we can now determine the moment of inertia with respect to x-axis by finding the summations of Ix1 to Ix4. Then, we use the same method to find the moment of inertia with respect to y-axis. The moment of inertia with respect to y-axis can be determined by adding Iy1 to Iy4. Next, we will use the formula square root of the moment of inertia divided by the total area of the hand truck to find the radius of gyrations with respect to x and y axis.
In order to analyze the relationship of the structure of a hand truck with static, we have solved various problems such as the action of axial, bending, and torsional load based on the free diagram that we have constructed. We also employ moment and inertia based on the analysis for problem solving due to the compound loads. Based on our observation, there's a few factors that cause failure and deformation. The first one is overloading, next rusting, and lastly shearing stress force. Overloading. Overloading means that the user puts loads that weigh more than the limit of the truck. Overloading the truck can cause failure and deformation to the structure of the hand truck. Any form of deformation can affect the performance of the hand truck, such as decreasing in stability, difficulty in maneuvering, and eventually it will break down. As you can see, when the base is bent in the middle as the picture shown in the bottom left, the surface becomes slanted to the middle, which will cause the loads to be slanted to the middle too. This will cause the force to distribute unevenly, which is the force will more focus on the middle instead of the front and the back of the truck. Hence, we have found a few ways to improve the problem. The first one is user needs to follow the limit if the hand truck is set by the limit set by the manufacturer. Next, we can change the structure of the hand truck, such as we can add support beams at the bottom of the base to strengthen it. Lastly, we can use a stronger metal such as tungsten. Why do we choose tungsten? Because tungsten has a higher yield strength compared to steel, which is tungsten has 750 megapascal and steel has only 550 megapascal. Rusting. It is natural for metal to rust when it is exposed to oxygen or water, and metal tend to break easily when it is rusted. When it breaks, it can form sharp surfaces which can hurt its user. User that hurt by a rust metal has a risk of getting tetanus. To solve the problem of rusting, we can use paint to paint the metal so that it won't be exposed to air and water. Instead of painting, we can also do powder coating, which is a more efficient and cost-saving method. Powder coating is a type of coating that is applied as a free-flowing dry powder. Unlike conventional liquid paint, which is delivered via an evaporating solvent, powder coating is typically applied electrostatically and then cured under heat or even UV light. The powder may be thermoplastic or a thermoset polymer, and it is mainly used for coating metals only. Unlike painting, which only lasts for a few years, then we need to paint it back again, powder coating can last up to 20 years, which will save a lot of cost on repainting our metal. Hence, powder coating the hand truck will solve the problem of rusting. Shearing stress. Shearing stress is a type of stress that acts coplanar with a cross-section of material. Shearing stress arises due to the shear forces. They are a pair of forces acting on opposite sides of a body with the same magnitude but opposite direction. In our case, we can see shear stress experienced at the tire of the hand truck, where the tire has friction with the ground. It will cause shear stress at the tire, which will make the tire to wear out easily. Next, we can look at the joint of the handle. When the user apply force to the handle, it will cause the joint to experience shear stress, which will make it to deform. So the solution that we come out with, we will add hinge support to the joint so that it can withstand a higher force, which will make the shear stress more minimal. Next, user need to always check on the tire of the hand truck so to see whether it has wear out or not. So when the tire has worn out, they need to change the worn out tire to a new tire so that no accident will happen when handling the hand truck. There are a few assumptions that we made while doing these experiments to ease our calculation. The first assumption that we made is the hand truck is in good condition, as it is in a new hand truck. So there is no damage, deformation, or wear out experienced by the hand truck. Next, we assume that the hand truck free body diagram is in a 2D dimensions. This is our calculation and it's easier to measure and construct the free body diagram. In a 2D dimension, which means that it only consists of x-axis and y-axis only. Next, the last assumption that we made is there is no external force experienced by the hand truck, such as the wind. This makes the hand truck always in equilibrium. According to Newton's first law, under the equilibrium condition, an object that is at rest will stay at rest, and an object that is in motion will not change its velocity.
So now I am going to give a brief conclusion for our presentation. In conclusion, static constructions can be seen all over the area. It serves a multitude of functions, all with the same goal in mind, which is to make people's life simpler. As a result, a variety of analyses can be carried out to establish whether a static system is fully functional and effective. The free body diagram method and its equilibrium are widely used to illustrate all of the forces and moments on a system. It is done in such a way that complex constructions are disassembled into their constituent parts using lines and simple shapes. Based on our calculations, we can say that we have achieved all of the learning outcomes which were required to be achieved in this assignment. We hope that more research into the hand truck can be done so that more improvements can be made. Aside from that, we hope that additional research into the hand truck will improve the safety of the user. That is all from us. Thank you.